For the conditional classifier, we have developed two different tools. One is for binary classification and one is for multi-class classification problem. And here this is the tool that I am showing is for binary classification problem. And so that here accuracy, precision, specificity, recall, all these things have been called. And here different databases that we have incorporated with. However, we can add some more also. Let's have some database here. So when I have selected from the glass database, we have collected it from UCI machine laboratory, and this data sets has been normalized to the distribution of feature 1, feature 2 like this. And here are total 9 features. In the class 1 we have 163 samples, in the class 2 we have 51 samples. If we do not want any compression, then just without compression, so reduced features no. And here the 10% I have selected as training and testing. So out of 163, 16 are for training for class 1, 147 for class 2, and likewise for the class 2 also. And this is the conditional classifier. Then I have trained this one, and after training you can find the conditional image, means after training the dictionary that has been obtained here. You can find like this by clicking on this one. So these are the binary condition vectors, and these are the difference matrix, and the last two are representing the probability and this thing. However, these are the false gray representation, so it is not much clear about how the probabilities are being distributed. Then after testing, so just you have to press this test, so train and test, and you can get all these accuracies. You can find the confusion matrix just by clicking over here. So how the confusion has been created, and like this the ROC curve also can be visualized by pressing the ROC curve here. Likewise, if anyone want to see how the feature is being the distribution of the features are, then this one and this one will be representing one x-axis and y-axis. This is the feature 1 and feature 4. However, one can change this thing, so automatically it will scale up to whatever that we have. So if we'll plot this, then you can see how the data are being. So here these are the training, and the black colored circles are the testing. So it's like almost so this is the training sample, but this is the testing sample. It is rounded with black color. And if you want to see the classification results, you can see like what are the samples that is not able to be classified as the original. So this is a handy tool that we have developed, and also it's like good for comparing different algorithms. Likewise, for other algorithms also, we can go for like decision trees, and let's train. So whereas the training starts, it will take some time, then training ends, and then testing. So testing ends. So now we can get the results of this thing also. So different classifiers can be changed, the percentage of training and testing can be changed, and one thing, the feature reduction again. So if you want to reduce the feature, then just select how much you want to reduce. So it is around this thing. If you want 4, so select any of the technique and just do this thing, so that you will find it has been reduced. So initially the feature was 9, but the reduced feature is 4. And out of this reduced feature, let's again divide this data into training and testing of 20%, let's think, and then go for this conditional classifier again and go for this testing, and you will find it is now it is 92.44. so it is almost okay, it is showing error because it is the 7, but we have selected 4 features. So let's now see this thing. So it is how the distribution is somehow different according to the PC reduced components. The data has been distributed differently. So this is how we can have everything. And also the hist represents the histogram of the data of the features. Like this is the feature 1 and feature 3. So normalized feature 1 and normalized feature 3. So how the distribution is, it is showing this thing. Okay, so this is all about the binary classifier. In the same manner, we have developed a multi-class classification tool also. So here, just let's say example of fisheries. It has three classes. In the same manner, if you don't want any reduction, just place over here. Then you select how much you want to train. So 545 like this. Then select the classifier, do the training, and then testing. So after testing, we found this is the accuracies that we got. So this is how I have incorporated with this. So here also we can see the feature relationship and the classification problems. Okay, and also the confusion matrix, how much restricted in what. Okay, so here we have evaluated the algorithms with the help of overall accuracy, average accuracy, and kappa coefficient, and this is the class specific accuracies for each class. What are the accuracies we have? So this is all about the two different tools that we have made for evaluating our classification algorithms. Thank you.